To solve a system of word problems, we need to have two equations. So when we're looking through our word problem, we're looking for what information can I use to write two separate equations. And there could be more than two equations, but for what we're using, we're going to just have two equations. And most of the time, not always, but most of the time, they're going to be in standard form, which is this. So we're looking for two different equations. That's going to give me a value of one thing, a value of another, and then a total. And then we'll get one or two other examples as well. So a pet owner buys cat food and dog food for $26.50, and then another customer, so we're going to write this person's order in one equation, and we'll write the other person's order in another equation. So the first order, 2 bags of, I'm going to use D for dog food, and I'll use C for cat food. So 2 bags at this price for dog food, plus 3 cans at this price for cat food, and altogether they spent $26.50. And the other customer buys 4 bags of dog food at this price, plus they also buy 1 can of cat food at this price, and they spent a total of $33. So this would be the two equations that I would then solve. You could solve using any method, so I would suggest using combination or elimination on this problem and make those C's cancel out. For number 2, we're talking about a group buys tickets and then another group, so we'll write one equation for the first group and another equation for the second group. We'll use V for VIP tickets, and I'll use R for regular tickets. So a group buys 3 VIP tickets at this price, plus they also buy 2 tickets at this price, and they spent a total of $310. And then another group, they bought 2 VIP tickets at this price, plus 4 regular tickets at this price, and they spent a total of $280. And again, once we have our equation set up, then you can choose which method. I would choose combination again, and I would choose to eliminate the R's. Number 3, this is trips to a store. So it says on another trip. So we'll write the first trip and then the second trip. So the first trip, we have 4 notebooks. Let's use N for notebooks, and we'll use P for pens. So 4 notebooks at this price, plus 5 pens at this price, and they spent a total of $23.50. Then on another trip, so then that's a separate equation, they bought 2 notebooks at that price and 3 pens at that price, and they spent a total of $12.50 during that trip. And then again, choose your method to solve. For number 4, this one's a little bit different because it doesn't quite give us as much information. An outdoor store sells both 4-wheelers and dirt bikes. We have 2 things. We'll use F for 4-wheelers, and we'll use D for dirt bikes. It says there are a total of 80 vehicles on the store's lot. So it has some number of 4-wheelers, plus they have a bunch of dirt bikes, and all together they have 80 vehicles. So this first equation represents the total number of vehicles. Number of 4-wheelers plus number of dirt bikes together is 80 vehicles. For the second equation, the store cleaned all the wheels. So this was talking about the number of vehicles. So then our second equation is going to talk about the number of wheels. So this is where it doesn't really give us information. We just have to know some information. It's talking about the number of wheels. A 4-wheeler has 4 wheels, so 4 wheels for each 4-wheeler, plus 2 wheels on each dirt bike. And it says that the wheels totaled 260. So then all the wheels together totaled 260. So now we have our second equation. And then this one would be good for combination elimination. It wouldn't also be hard to use substitution for this one if you wanted to. Number 5, a farm has 35 animals. It says the number of chickens is 5 more than half the number of pigs. So we know we're talking about chickens. Let's use C for chickens, and we'll use P for pigs. So let's first talk about this one. It has 35 animals altogether. So some number of chickens, we don't know how many, plus some number of pigs, and altogether there are 35 animals. So the first equation is just about the number of animals. And then the second equation is actually also going to be about the number of animals, but it's going to give us different information. So we also know, it says this, the number of chickens is. So in math, that word is means equals. So number of chickens equals, well, number of chickens is C. So number of chickens equals, that's what the is tells us, 5 more than, so I have to add 5 to something. 5 more than what? Half the number of pigs. So half the number of pigs. So again, let's go through that one together. The number of chickens is 5 more than half the number of pigs. And then this would be best for substitution. I can just take this value here. This is all C, and I could plug that in there for C and solve using substitution. And then number 6, this one's kind of back to the normal standard form again. So soccer team's ordering cookies. They have chocolate chip cookies, we'll use C. And they have monster cookies, we'll use M. So it says each chocolate chip costs $1.50. Each monster cookie costs $2.50. Then it tells us we have ordered 30 cookies altogether and cost this much. So let's write one equation for the cost. So for the cost, it's $1.50 per chocolate chip plus $2.50 per monster, and altogether they spent $55. And then the second equation, the only other information it gives us is that they ordered 30 cookies. So let's make this one the number of cookies. So we have some number of chocolate chip plus some amount of monster cookies, and altogether that made 30 cookies. And then you can use substitution if you get C or M by itself, or we can use combination again.